MASH's resource management is fairly comprehensive. This particular diagram is for a J2EE server topology. You can see we've got a basic two-tier design, the application server, Tomcat, which basically serves up static resources, icons, pictures. These are resized on the fly on the mobile devices themselves. And then we have the web server, which is not used for static resources, but more for the user-created resources, such as points of interest, whether picture, video, audio. The web server is also used for any network camera videos or pictures that are produced. And in these cases, the resources, the graphical resources, may be quite large, so they're actually scaled down into a variety of thumbnails as needed. And there currently isn't an ability to capture a frame for any submitted video from a network camera, so I just basically grab an image and throw that along with the video, and it seems to work fairly well. Apache, currently I'm using the file system to store this information, but shortly I'll have JDBC integration, and even in the J2EE case, we'll be able to store these resources in the database, which is obviously preferable to the file system, I believe. And we have external resources which are acquired from things like Twitter accounts and Facebook accounts. And once we go to the mobile device itself, we can see type and object caches. Once they're retrieved from the server, they're cached on the mobile device. Currently it's an in-memory cache. Shortly we'll write certain static files to disk, which seems appropriate. The format of all the mobile device object caches is of course JSON. For image and icon caches, it's JPEG and PNG. Additionally, on the mobile device, there are perimeter caches, which would be at a building, floor, or room level. And there's an ability to do an intelligent bulk cache flushing, whether it's at any level of perimeter you'd like, building, floor, or room. And that's actually utilized by the security service provider model. When someone gets kicked off as a monitor, their caches are basically flushed. So they're sort of reset back to that original state, and they don't see any of your components in your house, etc. In all cases, it's a shallow fetch that's being done, so it's fairly efficient on the mobile device. And when it comes to building an application, your choice of server component, whether it's J2EE server or an App Engine server, determines how a number of resources at runtime are actually created. And the kinds of resources that a server handles are things like threads, timers, which is very close to a thread. There's a generic storage interface, which is basic CRUD, and this is used for App Engine and J2EE to abstract out your file system blob storage concepts. And lastly, the server will handle the build sequence, which includes code generation through deployment. Now, the App Engine version of this slide would vary very slightly in that the two tiers would basically be collapsed, I believe, into a single tier. And of course, there's no local file system for storage. We'll be using the App Engine's blob storage backend for that.